Alright, as I mentioned, there are many types of sequences exist in the real world, and we would like to focus our attention on a very special type of sequence which has many applications in the real world. Okay, geometric sequence is one of the sequence that has many application in the real world. Now let me mention here that geometric sequence is a sequence constructed using two numbers only. I am going to label these two numbers. I am going to label first number as A, second number as R. Okay. Now this is how I am going to construct the term of the sequence. The first term of my sequence is going to be A. To get the next term, I am going to multiply the current term by r to the power 1. Remember, I'm going to use only two numbers here to formulate this sequence. Alright. First entry will be my first number A. To get the second entry, I multiply first entry by r to the power 1. To get the third entry, I multiply second entry by r to the power 1. Alright, so third entry will be AR square. Fourth term will be AR cube. Likewise, I want you to notice that each term has one less power of R than the term number. Alright, first term has 0 power of R. Second term has 1 power of R. Third term has 2 power of R. Right? So, power of R is 1 less than the term number. Nth term will have n minus 1 power of R. Okay, a sequence in this format is called a geometric sequence. All right, I would like to give you three remarks based on this definition. First two remarks, they are going to be the name of these two numbers that we have used. All right, let's give them a name. A, I am going to call it the first term of the sequence. All right, R, I am going to call it the common ratio. Remember why I call it common ratio? Because it's a ratio of any two consecutive terms. If you divide the second term by the first term, you get R. If you divide the third term by the second term, you get R. If you divide fourth term by the third term, you get R. If you divide nth term by n minus 1th term, you get R. Alright, so this is how the sequence is constructed, by multiplying current term by r to the power 1. So if you take the ratio of two consecutive terms, that's going to give you the value of r. And I call that second number a common ratio. Alright, to compute the common ratio, fairly easy. Take the ratio of any two consecutive terms. Alright, and the third remark is about the general term. The general term an is a times r to the n minus 1. Right? So here is the general term formula. We need to keep that in mind. Okay, I would like to give you one more interesting result associated with geometric sequence. Right? And this result discusses how to add first n terms of the geometric sequence. Alright, this is again a shortcut of adding first n terms of a geometric sequence. For example, if I ask you to add 100 terms of the geometric sequence, this is a long work, right? Because you have to add 100 terms. If you do it manually, it's going to take a long time. Alright, this result is a shortcut to do that addition. Okay, so let's see the result. Alright. If you know A and R, you should be able to compute, the sum of first n terms of the geometric sequence. And here is the result. A geometric sequence has first term A and common ratio R. Then the sum of first capital N terms, it's denoted by capital S sub n. And it is given by S sub n equal to, this is again adding capital N terms manually, right? First term, second term, third term, capital nth term will have one less power of r than the index n. Alright, so this is manual way to add them. We don't want to add them manually, right? Here is the formula to obtain sum of first n terms. All you need is a, r, and how many terms you would like to add. The formula is very simple. A times 1 minus r to the n over 1 minus r. Many textbooks, they write this formula in this way as well. If you factor negative 1 out from top and the bottom and cross it out, you can get this formula: a times r to the n minus 1 over r minus 1. Alright, you can use one or the other version. Feel free to use any version you like between these two. Okay, remember, the common error here is if you use the second formula, many students, they write r to the n minus 1. That n minus 1 they put in the power of r, which makes the computation incorrect. Alright, this minus 1 is a separate term. Okay, so be sure that you are aware of these minor things. So we so far have a definition of geometric sequence. We have three remarks: name of a, name of r, general term, and now we have a result that tells us how to compute sum of first capital N terms. Okay, time to see few examples. I would like to show you some really basic examples first. Suppose I give you a geometric sequence with first four terms given 2, 4, 8, 16 dash dash dash. What I want you to do is compute the first term and the common ratio. Alright, so compute a and r. Remember, to compute a and r, I only need two terms of my geometric sequence, and these two terms could be any two terms. Alright, if first and second term is given, it's fairly easy to compute a and r using them. Okay, once you have a and r, I want you to compute the general term. I want you to use that general term formula to compute the sixth term and the 10th term, and then I want you to compute formula for sum of first capital N terms in its simplest form, and then use it to compute sum of 5 terms and sum of first 9 terms. Okay, all right, let's do it one by one. Okay, so I know the first and second term. First term is 2, second term is 4, so a is 2, trivial. To compute r, I am going to take the ratio of two consecutive terms. Second term divided by first term, I get 2. If I would have done third term divided by second term, I would have gotten the same result. Fourth term divided by third term, still 2. Alright, so common ratio is 2 here. Compute an, it's a times r to the n minus 1. Alright, so again, here is another common error that students make. This n minus 1 power only applies to r. It has nothing to do with that a, and that is the reason why I kept a in the parenthesis and then r to the power n minus 1. So I have 2 times 2 to the n minus 1. If you remember, if you have two exponents sharing the same base, and if they are related with multiplication sign, you need to add the powers to simplify them further. Alright, not saying that this simplification will always occur, right? In this case it is occurring because our sequence is super duper simple. Alright, looks like I get 2 to the 1 plus n minus 1, that's 2 to the n. Alright, this is the general term. I can compute any term I want. I can now answer that third question. Sixth term will be 2 to the 6, which is 64. 2 multiplied with itself 6 times. 10th term, 2 to the 10, it is going to be 1024. 2 to the power 10 is 1024. Now let me mention here that if power of the common ratio is in 2 digits or more, again, if power of the common ratio is given in 2 digits or more, then on the exam or quizzes, feel free to leave your answer in this format. Alright, again, Feel free to leave your answer in this format if um, power of the common ratio is in 2 or more digits. All right, once again, it's perfectly fine if on the quizzes and exam, if you don't simplify common ratio to the power 2 or more digit number. If it's a single digit number, you need to simplify, but if it's a 2-digit number on quizzes and exam, we don't expect you to simplify it all the way. Homework assignment, you have access to calculator, so this number can be calculated without any hassle. Okay, so we have the 10th term as well. We can calculate sum of first capital N terms. We have a formula for that: a times 1 minus r to the n over 1 minus r, and this is going to be 2 times 1 minus 2 to the n over 1 minus 2. That 1 minus 2 is negative 1 in the denominator. Unusual to keep negative sign in the bottom, so I move it in the front. I really get negative 2 times 1 minus 2 to the n. Right? So if you want, you can split that negative 2 over both terms and then write it as 2 to the n plus 1 minus 2. I can now compute sum of first 5 terms. 2 to the 5 plus 1 minus 2. Just plug n equal to 5 in here. Simplified version of Sn. Needs to be Sn. 2 to the 6 minus 2 is just 64 minus 2, and that's 62. I can compute sum of first 9 terms. 2 to the 10 minus 2, which is 1024, minus 2, which is 1022. Again, if your computation of sum of first few term involves double or triple digit of the common ratio, then on the quiz and exam you can leave this as your final answer. You don't have to simplify it further. Okay, all right. Here is the next problem, very similar to the first one, slightly more tricky sequence. Suppose I give you the geometric sequence with entries 18, negative 12, 8, negative 16 over 3, and so on. The same 5 questions we would like to answer. All right, compute first term and the common ratio. Compute an. Compute fourth term, 15th term, and then compute sum of first 4 terms and sum of first 20 terms. All right, so fairly easy to do this computation. Let's compute a and r using the first and second term. First term is 18. Common ratio is negative 12 over 18, which is negative 2 over 3. Okay, I can compute the general term an, which is a times r to the n minus 1. 18 times negative 2 over 3 to the power n minus 1. One more thing that I would like to mention here is I cannot take this negative sign outside because we don't know whether n minus 1 power is an even number or the odd number. Alright, many students, they bring that negative sign outside. Please don't do that. If n is 4, then you have odd power of this entry, the result will be negative. If n is 5, then 5 minus 1 is an even number. This expression is already positive. Alright, so understand that negative sign cannot be taken outside. Okay, alright. I can calculate the sixth term by simply substituting n equal to 6 in an. I get 18 negative 2/3 to the 6 minus 1. This is 5 power of negative 2/3, which is negative 32 over 243. If you cross out 9 from the top and the bottom, you get negative 64 over 27. So as I said, there is no trick here. Once you have a and r with you, you can compute the general term, and once general term is known, you can calculate any term you want. Okay, all right. 15th term, as you see, I left my answer in form of common ratio to the power double digit. Perfectly fine to do that. We can now calculate the sum of first n terms. This needs to be S sub n, alright, so it is S sub n, okay. Sum of first n terms, a times 1 minus r to the n over 1 minus r, or you can use a times r to the n minus 1 over r minus 1. I get 18 times 1 minus negative 2/3 to the n divided by 1 minus negative 2 over 3. If you simplify the denominator, you get 3 plus 2 over 3, which is 5 over 3. Bottom of the bottom will go into the top. So I get 54 over 5 times 1 minus that common ratio to the power n. Okay, this is the simplified form of sum of first capital N terms. Well, I can calculate sum of 4 terms now. Plug n equal to 4. If you do that, you get 54 over 5 times 1 minus 16 over 81, right? Find the common denominators, simplify it further, you get 54 over 5 times 65 over 3. Cross out the repeating entries in the top and the bottom. The final result is 26 over 3. Alright. Likewise, you can calculate 28th term, sum of first 20 terms. Fairly easy to do. Just put n equal to 20 in here and you're done. Right? As I said, no need to simplify if power of r is in 2 or more digit. Okay. On the exams and quizzes. On the homework, your calculator can calculate this number easily. Alright? Okay, so let's try to discuss one very interesting problem. Compute the 7th term of the geometric sequence for which the 3rd term is 3 and 4th term is 9. Okay, suppose I give you a geometric sequence whose 3rd and 4th term is given to you, and you would like to calculate the 7th term. Want you to notice that 2 consecutive terms are given. As I said, to calculate a and r, I only need any 2 terms of my sequence. Alright? So 2 terms are given. I need a and r. What I want you to do first is write down 3rd and 4th term in form of a and r first. And once you have these 2 terms in form of a and r, we can easily compute a and r. Okay, so let's write down the 3rd term in form of a and r. It is going to be a times r to the power 1 less than the term number. So a r square equal to 3 and a r cube equal to 9. Okay, so we have our 3rd and 4th term in form of a and r. The question is, we would like to solve this for a and r. What is the best way to solve it for a and r? I would like to eliminate one of the variable. Okay, so looks like both of this contains power of a and r, one power of a and different power of r. If I take the ratio of 4th and 3rd term, I will be able to get rid of a from top and the bottom. So let's divide the 4th term by the 3rd term. What do I get? AR square will be gone. So I really get R equal to 9 over 3. And 9 over 3 is 3. So I got R value. Plug this R value either in A3 or in A4 and solve for A. Okay, so look, I plug R equal to 3 in the second in A3. I end up getting A equal to 1 over 3. Alright, so I got my A value. Now we have A and R. We can easily compute the 7th term. 7th term is AR to the 6. 1/3 3 to the 6. Really get 3 to the 5 there, which is 243. We can make it slightly more interesting. Compute the sum of first 5 term of the geometric sequence with the 3rd term 2 and 6th term 16. All right, so I give you two terms that are little far from each other. We are going to use the same logic to solve it. The third term, suppose it is AR square. The sixth term is AR to the 5. So I have AR square equal to 2, AR to the 5 equal to 16. And now I am going to solve this for R. Divide the sixth term by the third term. So AR to the 5 over AR square. On the other side, divide 16 by 2. You really get R cube equal to 8. Alright. The number whose cube is 8 is 2. So I get R equal to 2, and I'm going to plug R equal to 2 either in my third term or in my sixth term. Third term looks reasonably simple, so I will plug R equal to 2 in here. A times 2 square equal to 2, and that gives me A equal to 1 by 2. Alright, I know A and R now. I can calculate sum of first 5 terms now. Alright, in order to calculate sum of first 5 terms, all you have to do is use the formula A times 1 minus R to the n over 1 minus R. We know first term, we know common ratio, we know how many terms we are going to add. Plug them in. So A is 1 by 2, so I kept that 1 by 2 outside. And then I have 1 minus 2 to the 5 over 1 minus 2. Looks like I get 1 by 2 times 1 minus 2 to the 5 is really negative 31 divided by negative 1. So this is really negative 31 over 2. Alright, so this is what we have for this lecture.